Here's one more to try. If the brightness is reduced, what's going to happen to the voltage measured on the voltmeter and the current measured on the ammeter? This is pretty tricky. Actually, it's downright nasty. Calling it a challenge doesn't really do it justice, to be honest. Anyway, pause the video, write and work it out. If you get stuck, then watch on. But if you're nervous about this topic already, just skip this video. It's okay, don't worry. Still here and you gave it a try? Don't just watch this without having a go first. It's not really going to help you. Engaging your brain is the only way you're going to really understand this. Right, so the brightness reduces. That means the resistance of the LDR increases. That means the resistance of this parallel section increases. So it's going to take a bigger share of the total PD. So the voltage on a voltmeter goes down. For current, the total resistance of the circuit increased. So the total current went down. This smaller current is shared by the LDR and 10 ohm resistor as they are in parallel. Since the LDR has a higher resistance, a higher proportion of the current will go through the 10 ohm resistor. This is getting tricky. Let's put some numbers in. Assume the resistance of the LDR increases from 10 ohms to 20 ohms. And EMF is 2.5 volts. At first, the total resistance of the circuits is this. Parallel part first. Add 20. So the current is 0.1 amps. Half of that goes through the ammeter. So at first the current is 0.05 amps. With a higher resistance, 20 ohms, parallel part, add 20 gives us 26.7 ohms. So the current is 0.09 amps total. 2/3 of that goes through the 10 ohm resistor because it only has 1/3 of the overall resistance. And 2/3 of 0.09 is 0.06 amps. The current increased from 0.05 to 0.06 amps. So quite a tricky problem there. You're probably not going to get anything quite that long really to answer, but hopefully you followed through and you should see you've got the skills to answer something like that, even if it would be quite a challenge to do it under examination conditions.